Working now.
So she can hear us?
Yep, she can hear us. Now say it.
Hey, Lily.
All right.
Moon landing mistake.
They're trying to get me off task. CSC!
Kobe.
I just asked this question a couple periods ago to the calculus class. And it's one thing we know at cosecant x. Ms. Stonebreaker. What's the one thing we know at cosecant x?
I don't know. It's the opposite of something.
It's the opposite of something. That's at least something.
It's the reciprocal of
1 over sine,
Sine.
folks. Write it down. We need that for later.
You're welcome, Lily.
You guys are all embarrassing me right in front of Lily. Secant x. What's the one thing you know about and only Stonebreaker? What's the one thing you know about secant x?
That's 1 over cosine.
1 over cosine x. Love it. What's the one thing you know about cotangent x?
1 over tangent.
1 over tangent x. Now we're doing really good. Now I need you to put an equal sign there, but not to fill it in.
equals.
Oh, no.
Just for that one.
We're going to come back to it later, just for that one.
Okay.
Now we're going to move forward. I've got sine of x plus 360 degrees n. Now there's not a degrees on there. You need to put that in there because it's wrong without it. And we'll move around the room. We'll say, Miss Eppolito, what is sine of x plus 360 degrees n? Huh? We've never done anything like that before, Miss Jody. Yes, but think about it. This is a phase shift, isn't it? So we're shifting at 360 times some number like 2357. What happens when I pick up a graph? I lift it up and then I move it over 360, put it down?
Nothing.
Nothing. What if I do it twice?
Nothing.
How about 100 times?
Probably nothing.
Probably nothing. So therefore, sine x plus 360n is equal to sine x, because nothing happened.
What?
How did you have as a phase shift actually? I think I forgot last time.
Because remember, it's inside the parentheses with a plus. That's the c.
Oh, C. Okay.
That's c.
Let's see. Got it.
All right, cosine of x plus 360 degrees n.
Same thing.
What's that going to be?
Same thing.
So it'll be
That's what it is.
cosine x. Love it. So far, so good. This is an easy chapter. We love this chapter. Let's keep doing problems like this until our brains melt. Speaking of brains melting, let's try this problem. Sine of negative a is equal to Mr. Stranzel. I'm going to argue that's equal to negative sine a. So I'm going to do a little exploring to think about how that could possibly be. Taken literally, that means that the sine of negative 30 degrees would be equal to the negative sine of 30 degrees. Is that true?
According to that, yes.
According to that, but is that true in real life? 30 degrees would be this way, right? And what's the sine of 30 degrees?
1/2.
1/2.
I don't know.
And what's the sine of negative 30 degrees?
Same thing.
Except that it's all sad tigers cancer.
Right.
So it's negative.
So it's going to be negative 1/2, right?
Yeah.
So sine of negative 30 degrees would be negative 1/2 is equal to negative positive 1/2,
Whoa.
which is true.
Can you repeat that?
The sine of negative 30 degrees, which would be negative 1/2, is equal to negative sine of positive 30 degrees, which is 1/2. Right?
I guess. But a negative doesn't equal a positive.
Well, it's interesting. It means the negative can be pulled out of this expression. Follow this, though. Why? The y is simple because this reference angle is the same as this reference angle, right? So it's always going to have the same numbers. Even if I go over here, this reference angle will be the same as this reference angle there, right? So it always has the same reference angle. So the numbers are going to be the same. And if I'm in the first quadrant or the fourth quadrant, the signs are always going to be opposite of each other, right? And if I go in the second quadrant and the third quadrant, again, the signs are still going to be opposite of each other. And even if I keep going and go into the second quadrant by backwards and go this way to the third quadrant, they're still going to have opposite signs, aren't they? I'm looking at Stranzel's face, and I have no idea whether he's got it or not, or he's contemplating, are there taquitos after school? One of those three things is going on. I just don't know what. What's going on, Mr. Stranzel? Does that make sense? Let me back up. Reference angles are going to be the same, right?
Mhm.
So therefore, half, sine's the only thing that could possibly be different, right? Because if I go over here to this quadrant, these are the same angles, which means these are the same angles, which means the reference angles are the same.
Yeah.
Always going to give you the same answer, regardless.
Okay.
That said, what's going to happen to the signs? Well, the signs are always going to be opposite of each other, right? If this one's positive, this one's in the negative quadrant. If this one's positive, which is also because all sad, there's a sign, and this one's in the negative quadrant. If I go so far as to get to here, this one will go all the way to here. So this one will become negative, and this will still be the opposite sign because it'll be in the positive land.
Mm.
That make sense?
Yeah, but why would it go all the way up there?
I'm just saying whatever angle you pick.
Okay.
You make any angle you want. It's going to work. That's my point.
Okay.
Got it?
Yep.
All right. Mr. Cornell, let's hope he was paying attention.
Mhm.
You get to make the next argument.
Okay.
What's the next argument?
About cosine of negative a equaling cosine of s.
Cosine of negative a is equal to cosine of a. Oh, that's weird. How could that be? What do you got for me?
Two wrongs don't make a right, so therefore there's a wrong and a right. And therefore the-
I'm sorry, are you Mr. Cornell?
Cornell's got to do this one.
Could be one day.
Cornell, get in the game.
Oh! I could be one day.
Okay, so if you had
Sorry.
Yes.
it's because if you flip the angle
Mhm.
just across.
So let's
the
say I got
x-axis.
60 degrees because we like a half. 60 degrees, negative 60 degrees. This would be a half. This would be a half. With it, this positive or negative?
It's positive.
It's
because
positive.
Cosine doesn't have the opposite. It's
Right.
just adjacent.
Excellent thinking. I'm going to say all sad tigers cancer. So this quadrant is also a positive. What you said is better than what I just said. So I'm not correcting you. I'm just making sure everybody's with me.
Okay.
Okay, so this positive, that's positive, right? So if I go negative 60 degrees or I go positive 60 degrees, they're both positive. And they're both the same reference angle, right? So therefore, they have to have the same answer. Also, if I go out to here, what happens? If I go 120 degrees or negative 120 degrees, what happens?
We'll do this all.
Reference angle is still 60 degrees, so they're still both a half. And then the signs are both negative. So this is also true.
So,
So the sine of negative 576 degrees is equal to the sine, sorry, I just said sine, terrible. The cosine of negative 576 degrees is equal to the cosine of 576 degrees.
Explain
That's
why.
all we're saying. Because the reference angle is the same, so the numbers are going to be the same. And in the first quadrant it's positive, so it's also, cosine is positive also in the fourth quadrant. So these two are both positive, so their signs are the same. The amount is the same, so therefore they have to be the same. Even if we go to the second quadrant, they both become negative. But that means they're still equal to each other, right? So that's funky and weird, and it's joy of trig. We'll move forward, though, because we got to do the two most important yes, ma'am.
okay, so does it work the other way around now? Like cosine of A equals cosine of negative A?
So what's like the bigger picture with this?
True.
Oh, the bigger picture is we're just getting more. Don't look behind the curtain just yet. Just give me a little time to get things set up. By the end of this class period, you'll have a better idea what the picture is, and you'll be saddened deeply by it. And I will help you with that sadness.
All right.
But after I've frustrated you with the sadness, I got to frustrate you first. There are two identities you must know. It's the next two. You have to know these. I've already given you the first one in an attempt to help you with your memorization. Sine x over cosine x, if you remember correctly, I pointed out that sine is opposite over hypotenuse, and that cosine is adjacent over hypotenuse. Now moving forward, Ms. Krolik, how do I take a fraction divided by a fraction? What do I do? Flip and multiply. So that would be opposite over hypotenuse times hypotenuse over adjacent. And I know, because I know how to do fractions, that these two cancel out. And that gives me opposite over adjacent. What is opposite over adjacent? So close. Almost got it. That's tangent of x. So tangent of x is equal to sine x over cosine x. That is huge. You have to know that one.
Wow, so but we only have to know. Okay,
Yeah, don't, all the steps in between, we're going to completely forget how we got there.
So
We just need to have that end point.
So it equals
Just know
10.
that tan x.
So we don't even know any of the ones that we just did, just this one?
That one you have to know.
What the other ones were.
Okay. Now,
You just-
well, you mean the cosine ones? Those you should vaguely be aware of and maybe look back up from time to time if you need them. But this one is huge. This is like star asterisk. If you don't know this, you're pretty much going to get a 3 on the next test. So just anticipate that. You need to know this one. Also, it is in your best interest to know the following. Cotangent of x is the inverse, right? So cotangent of x would be cosine x over sine x. This is one you don't have to have memorized, but if you don't, you get to do extra work. You can still get an A on the test. You're just doing more steps than everybody else. Flipping stuff that everybody else is already just writing down their paper. Okay? All right. Now, those two are important. Well, actually, this one is hugely important. This one is going to help your life out in small ways. The next identity is so hugely important it defies description. And that is,
The next one's even more important.
oh yeah, this is the one. This is the one, half the time when a student walks up to me and says, Mr. Resney, I can't do this problem, I look and go, that's because the bells aren't ringing. And you're like, the bells aren't ringing. So I want you to think about this. When you see this identity, when we get done with this identity, but get done proving this identity, you have to walk home chanting it out loud until the police show up. Okay? Because you're talking to yourself about strange things. Cosine squared plus sine squared. I'm going to go ahead and do this. Sine squared is opposite over hypotenuse. That whole thing squared plus adjacent over hypotenuse. That whole thing squared equals, I don't know yet. Theoretically, you all know how to square fractions. I found out the other class period does not.
Oh, we don't know.
Oh, you do top and bottom.
At least
Yeah, you square top and bottom. So this would be opposite squared over hypotenuse squared plus adjacent squared over hypotenuse squared. And that means that the top is opposite squared plus adjacent squared, because I have a common denominator, over hypotenuse squared. Miss Stonebreaker, what is opposite squared plus adjacent squared? I don't know. Why are you asking? You know the answer. Let me draw a triangle for you. Here's a triangle. Here's my angle. Here's my right angle. This is the opposite. That's the adjacent. What is it? It's hypotenuse squared, is it not? Which means I have hypotenuse squared over hypotenuse squared, which is what?
Nothing.
1.
You can't decide.
1. So sine squared plus cosine squared is 1. If you don't remember this, you're going to be doing sine to the 4th times sine to the 6th, and I'll be like, what are you doing over there? You'll do things like I got sine x times sine squared x plus cosine squared x equals 1, and you'll be distributing.
I'm so confused.
This is 1. So look how much better your life would be.
Okay.
When does sine x equal 1? Much easier than when does sine cubed x plus cosine squared x sine x equal 1. Good luck doing that sometime soon. So this one's huge. It's magical. You must know it.
Do I have to know how you got to it?
No, you need to know it.
How'd you